everyone, this is Neslov A. Seliksik and this is my first time ever vlog about the coronavirus or COVID-19 pandemic. So this vlog is all about the COVID-19, its significance, nature, and origin. So that's it. So let's start. Coronaviruses are a family of contagious viruses that can cause respiratory infections from the common cold to SARS. These viruses can mutate rapidly, resulting in the 2019 new coronavirus named SARS coronavirus 2, which has crown-like spikes that characterize the family as with most viruses. SARS coronavirus 2 commonly spreads from an infected person to others through droplets in the air, when coughing or sneezing through close personal contact, or by touching a contaminated surface and then touching the face. Unless controlled, each infection typically results in 2 to 3 subsequent people being infected. People being infected, like other coronaviruses, SARS coronavirus 2 deposits its genetic material into host cells, the viral RNA, which is host elements called ribosomes, which act as factories that produce viral proteins. This facilitates replication of the viral genome and assemble of viral components, producing fully formed replicants it has secreted and further spread infection. Infection caused by SARS coronavirus 2 is known as COVID-19 and can cause fever, coughing, and breathing difficulties along with cold-like symptoms. Serious cases of COVID-19 can cause pneumonia, severe acute respiratory syndrome, kidney failure, and can lead to fatalities. Global Health Organization have outlined preventive measures to reduce the chances of SARS coronavirus infection, including refraining from touching the face with unclean hands and frequent hand washing with soapy water. As with previous global outbreaks, such as swine flu, COVID-19 has gained global attention and treatment development is being accelerated. The analysis of public genome sequence data from SARS-CoV-2 unrelated viruses found no evidence that the virus was made in a laboratory or otherwise engineered. By comparing the available genome sequence data for known coronavirus strains, we can firmly determine that the SARS-CoV-2 originated through natural processes, said Christian Andersen, a doctor of philosophy and associate professor of immunology and microbiology at Scripps Research and corresponding author on the paper. The novel SARS-CoV-2 coronavirus that emerged in the city of Wuhan, China, last year and has since caused a large-scale COVID-19 epidemic and spread to more than 70 other countries is the product of natural evolution, according to the findings published today in the journal Nature Medicine. In addition to Anderson, authors on the paper, the proximal origin of SARS-CoV-2 include Robert F. Gary of Tulane University, Edward Holmes of University of Sydney, Andrew Rambout of University of Edinburgh, W. Ian Limkin of Columbia University. Coronaviruses are a large family of viruses that can cause illnesses ranging widely in severity. The first known severe illness caused by a coronavirus emerged with the 2003 Severe Acute Respiratory Syndrome or SARS epidemic in China. A second outbreak of severe illness began in 2012 in Saudi Arabia with the Middle East Respiratory Syndrome or MERS. On December 31 of last year, Chinese authorities alerted the World Health Organization. On December 31 of last year, Chinese authorities alerted the World Health Organization of an outbreak of a novel strain of coronavirus, causing severe illness, which was subsequently named SARS-CoV-2. As of February 20, 2020, nearly 167,500 COVID-19 cases have been documented, although many more mild cases have likely gone undiagnosed. The virus has killed over 6,600 people. Shortly after the epidemic began, Chinese scientists sequenced the genome of SARS-CoV-2 and made the data available to researchers worldwide. The resulting genomic sequence data has shown that Chinese authorities rapidly detected the epidemic and that the number of Covid-19 cases have been increasing because of human-to-human transmission after a single introduction into the human population. Anderson and collaborators at several other research institutions used this sequencing data to explore the origins and evolution of SARS-CoV-2 by focusing in on several telltale features of the virus. The scientists analyzed that the genetic template for spike proteins are matures on the outside of the virus that it uses to grab and penetrate the outer walls of human and animal cells. More specifically, they focus on two important features of the spike protein: the receptor binding domain, or RBD, a kind of wrapping hook that grips onto host cells, and the cleavage site, a molecular can opener that allows the virus to crack open and enter the host cells. So these are the evidence for natural evolution of coronavirus. The scientists found that the RBD portion of the SARS-CoV-2 spike proteins had evolved to effectively target a molecular feature on the outside of human cells called ACE2, a receptor involved in regulating blood pressure. The SARS-CoV-2 spike protein was so effective at binding the human cells. Are coronaviruses new? Coronaviruses were first identified in the 1960s, but we don't know where they come from. In fact, that the scientists concluded it was the result of natural selection and not the production of genetic engineering. This evidence for natural evolution was supported by data on SARS-CoV-2's backbone, its overall molecular structure. If someone were seeking to engineer a new coronavirus as a pathogen, they would have constructed it from the backbone of a virus known to cause illness. But the scientists found that the SARS-CoV-2 backbone differed substantially from those of already known coronaviruses and mostly resembled related viruses found in bats and pangolins. These two features of the virus, the mutations in the RBD portion of the spike protein and its distinct backbone, rules out laboratory manipulation as a potential origin for SARS-CoV-2, said Anderson. Josie Golding, a doctor of philosophy, epidemics lead at UK-based Wellcome Trust, said that the findings of Anderson and his colleagues are crucially important to bring an evidence-based view to the rumors that have been circulating about the origins of the virus of SARS-CoV-2 causing COVID-19. They conclude that the virus is the product of natural evolution. Golding adds, ending any speculation about deliberate genetic engineering. So, these are the possible origins of the virus. Based on their genomic sequencing analysis, Anderson and his collaborators concluded that the most likely origins for SARS-CoV-2 followed one of two possible scenarios. In one scenario, the virus evolved to its current pathogenic state through natural selection in a non-human host and then jumped to humans. This is how previous coronavirus outbreaks have emerged, with humans contracting the virus after direct exposure to civets or SARS and camels or MERS. The researchers proposed bats as the most likely reservoir for SARS-CoV-2 as it is very similar to a bat coronavirus. There are no documented cases of direct bat-human transmission, however, suggesting that an intermediate host was likely involved between bats and humans. In the other proposed scenario, a non-pathogenic version of the virus jumped from an animal host into humans and then evolved to its current pathogenic state within the human population. For instance, some coronaviruses from pangolins, armadillo-like mammals found in ancient Africa, have an RBD structure very similar to that of SARS-CoV-2. A coronavirus from a pangolin could possibly have been transmitted to a human, either directly or through an intermediary host, such as civets or ferrets. In this scenario, both of the distinctive features of SARS-CoV-2 spike protein, the RBD portion that binds the cells and the cleavage site that opens the virus up, would have evolved to their current state prior to entering humans. In this case, the current epidemic would probably have emerged rapidly as soon as humans were infected, as the virus would have already evolved the features that make it pathogenic and able to spread between people. Then, the other distinct spike protein characteristics of SARS-CoV-2, the cleavage site, could have evolved within a human host, possibly via limited, undetected circulation in the human population prior to the beginning of the epidemic. The researchers found that the SARS-CoV-2 cleavage site appears similar to the cleavage site of strains of bird flu that has been shown to transmit easily between people. SARS-CoV-2 could have evolved such a virulent cleavage site in human cells and soon kick off the current epidemic, as the coronavirus would possibly have become far more capable of spreading between people. If the SARS-CoV-2 entered humans in its current pathogenic form from an animal source, it raises the probability of future outbreaks, as the illness-causing strain of the virus could still be circulating in the animal population and might once again jump into humans. The chances are lower of a non-pathogenic coronavirus entering the human population and then evolving properties similar to SARS-CoV-2. Study co-author Andrew Ramboat cautioned that it is difficult, if not impossible, to know at this point which of the scenarios is most likely. Funding for the research was provided by the U.S. National Institutes of Health, the Pew Charitable Trust, the Wellcome Trust, the European Research Council, and an ARC Australian Laureate Fellowship. So what is the symptoms of coronavirus or COVID-19? People may be sick from the virus for 1 to 14 days before developing symptoms. The most common symptoms of coronavirus disease or COVID-19 are fever, tiredness, and dry cough. Most people, about 80%, recover from the disease without needing special treatment. More rarely, disease can be serious and even fatal. Older people and people with other medical conditions such as asthma, diabetes, or heart disease may be more vulnerable to becoming severely ill. A coronavirus is a kind of common virus that causes an infection in your nose, sinuses, or upper throat. They're called coronaviruses because under a microscope they look like a crown. Coronavirus disease 2019 or COVID-19 is a disease that can cause what doctors call a respiratory tract infection. It can affect your upper respiratory tract, sinuses, nose and throat, or lower respiratory tract, the windpipe, and lungs. The COVID-19 outbreak quickly spread around the world. It spreads the same way other coronaviruses do, mainly through person-to-person contact. Infections range from mild to serious. COVID-19 is one of the 7 types of coronaviruses, including the ones that cause severe diseases like Middle East Respiratory Syndrome, MERS, and Sudden Acute Respiratory Syndrome or SARS. The other coronaviruses cause most of the colds that affect us during the year, but aren't a serious threat for otherwise healthy people. Many people who got the disease early on were linked to a large live seafood and animal market in China. You might hear it called a wet market. The first cases may have come from the animals sold in the market, then spread from person to person. How does the new coronavirus spread? SARS-CoV-2, the virus, mainly spreads from person to person. Most of the time, it spreads when a sick person coughs or sneezes. They can spray droplets as far as 6 feet away. If you breathe them in or swallow them, the virus can get into your body. Some people who have the virus don't have symptoms, but they can still spread the virus. You can also get the virus from touching a surface or object the virus is on, then touching your mouth, nose, or possibly your eyes. Most viruses can live for several hours on a surface that they land on. A study shows that the Covid-19 coronavirus can last for several hours on various types of surfaces, like copper 4 hours, cardboard up to 24 hours, plastic or stainless steel 2 to 3 days. That's why it's important to disinfect surfaces to get rid of the virus. How do you prevent the spread of coronavirus or Covid-19? If you're in an area where it's spreading, take these steps. First, wash your hands, often with soap and water, or clean them with an alcohol-based sanitizer. This kills viruses on your hands. Second, practice social distancing because you can have and spread the virus without knowing it. You should stay home as much as possible. If you do have to go out, stay at least 6 feet away from others. Third, don't touch your face. Coronaviruses can live on surfaces you touch for several hours. If they get on your hands and you touch your eyes, nose, or mouth, they can get into your body. And the last one is clean and disinfect. You can clean first with soap and water, but disinfect surfaces you touch often, like tables, doorknobs, light switches, toilets, faucets, and sinks. Use a mix of household bleach and water with 1/3 cup bleach per gallon of water, or 4 teaspoons bleach per quart of water, or a household cleaner that's approved to treat SARS-CoV-2. You can check the Environmental Protection Agency or EPA website to see if yours made the list. Wear gloves when you clean and throw them away when you're done. Antibiotics won't help people, they treat bacteria, not viruses. If we hear about people with COVID-19 getting antibiotics, it's for an infection that came along with that disease. What is the treatment for COVID-19 or coronavirus? There's no specific treatment for COVID-19. People who get mild case need care to ease their symptoms like rest, fluids, and fever control. You can take over-the-counter medicine for a sore throat, body aches, and fever. But don't give aspirin to children or teens younger than 19. You might have heard that you shouldn't take the ibuprofen to treat COVID-19 symptoms. The World Health Organization made that statement in March 2020, but they reversed it soon after and said there's no proof that taking it causes any harm. Is there a vaccine of coronavirus or COVID-19? Not yet, but clinical trials are underway in the United States and in China to test vaccines for SARS-CoV-2 or COVID-19. One vaccine called mRNA 1273, which was developed by using messenger RNA, would tell your cells to pump out a protein that will kickstart your immune system to fight the virus. It's worked well in animals and it is ready to test in humans. Those with severe symptoms need to be cared for in the hospital. Numerous clinical trials are underway to explore treatments used for other conditions that could fight COVID-19 and to develop new ones. Several studies are focused on an antiviral medication called remdesivir, which was first created to fight Ebola. A study in China showed that hydroxychloroquine and chloroquine, which are used to treat malaria and autoimmune conditions like rheumatoid arthritis, and lupus help people with COVID-19 pneumonia. Almost everyone gets a coronavirus infection at least once in their life, most likely as a young child. In the United States, regular coronaviruses are more common in the fall and winter, but anyone can come down with a coronavirus infection at any time. Are coronaviruses new? Coronaviruses were first identified in the 1960s, but we don't know where they come from. How dangerous is the new coronavirus? Global alarm mounts over a rapidly spreading new coronavirus in China. But just how worried should you be? The fast spread of a new coronavirus in China has prompted global alarm, with neighboring states closing their borders, global airlines suspending flights, and some governments barring entry to foreign nationals who have recently been to the Asian country.
Thank you for watching. Just subscribe, click the bell, like, comment, and share my YouTube channel, Goddess of Trends.